Continuing with algebraic analysis of limits, we're going to look at a piecewise function. Now we're going to use the graph to write the equations and go from there. So this first piece is this linear equation. It's got a slope of -1. And if it kept going, it would have a y-intercept of -5. But that's only for when x is less than -3. The next piece is a quadratic whose vertex is at -1, so it's moved left 1 and down 6. Now that's only between -3 and 2, but when x is 2, there's actually a point there, so we're going to include that point on the piecewise. The third piece is linear, has a slope of down 1 over 2, and a y-intercept of -1. And that's for when x is bigger than 2. Not equal to, because it's an open circle. If you haven't had a lot of experience with piecewise functions, I'm going to have a link to another video that might help you out. So, notice that the instructions say to use the equation. If it says to use the equation, you want to make sure you've shown that you've used the equation. So, as x approaches 2 from the right, so from the right of 2, this is to the right of 2, so we're going to use that equation. So -1/2 times 2 is going to give me a -1, minus 1 is -2. The limit as x approaches 2. Well, to use the equation, to make sure that this exists, we have to check the limit as x approaches 2 from the left, which means I need to plug in to that quadratic. So 2 plus 1, that's 3 squared minus 6, that's 3. So when it doesn't say a direction, this one doesn't exist because the right side and the left side don't match. So I would make sure I stated that anytime you say that it doesn't exist. Okay. X approaches -3 from the left. So -3 from the left side would be this equation. Turns into +3 minus 5, which is -2. Now if I go to -3 from the right side, I need to use the quadratic. That's going to be 4 minus 6, which is -2. So that one, if it had a follow-up question, the limit as x approaches -3, just overall, it does exist, because both of those pieces of the graph meet the same point. The limit as x approaches -7. Well, that's in this group, so we use that piece. as x approaches -1. Well, -1 lives between -3 and 2. So we're going to use that. Zero, so that's just -6. What if we didn't have a graph? Ooh, okay. So as x approaches -2 from the left, that would mean we use this piece of the piecewise. 2 times -2 squared plus 3 times -2. It's 2 times 4 minus 6 gives me a 2. From the right side means I'm going to choose this piece of the graph. So that's going to be a +1. So what is the limit as x approaches -2 of g of x? Well, it's 2. It doesn't matter which side we looked at. Now I'm going to continue on with some of these further examples. Go through them if you'd like. Pause if you need to. So let's see, if I plug in e, natural log of e over 2 times e. Natural log of e is just 1. If I'm going 5 from the left side, it doesn't matter, that's a quadratic. Easy one. Sine squared and cosine are all nice, pretty graphs. So this really means that we're going to take sine of the angle and then square it. So that's sine of pi plus 2 cosine pi. Sine of pi is 0. And cosine of pi is -1. Easy. Now the next one, you may have to think back a little bit on your charts. You should know your unit circles. So 5 pi over 3 is going to be in the negative, so both of them are going to be negative. Sine would be square root of 3. And cosine would be 1. In the denominator, we're squaring, so 25 pi squared over 9. Fraction over a fraction. We're going to flip the denominator. That's going to be 2's cancel. Square root of 3 over 25 pi squared over 9, dividing by a fraction. So for me, the hardest part was remembering my sines and cosines for this. Everything else is just manipulation. Okay, next one. I'll go ahead and give you a hint. As soon as I see a rational function, I want to try to factor. And it doesn't hurt to do it, so do it. The limit as x approaches -2 of x times x is x squared. What multiplies to be -6 and adds to be a -1? That's -3 and a +2. We can factor out a 2 out of the denominator. And now we can plug in -2. Okay, this one's kind of interesting. If I plug in 3, I'm going to have 0 in the denominator, which means I've got a vertical asymptote. And I know things about rational functions. I know it's going to be going differently. It's going to be, one of them's going to positive infinity, one side's going to negative infinity. So I can go ahead and say this does not exist. We can't really say anything because x equals 3 is a vertical asymptote. This next one's going to be pulling back into the way back of your algebra 2. I'll go ahead and give you some hints. I see 8x cubed and 2x. 2x cubed is 8x cubed, and 3 cubed is 27. So I have the difference of cubes. So let's remember some things. If I have a cubed minus b cubed, it's a minus b, then a squared plus ab plus b squared. If it had been a cubed plus b cubed, this would be a plus b, a squared minus ab plus b squared. So this one's following the top rule. So that's 2x minus 3. First thing squared plus those two multiplied together, plus 9 over 2x minus 3. I need to keep the limit in there for a little bit. The limit as x approaches 3/2 of 4x squared plus 6x plus 9. And now you can do direct substitution. Sorry. Turned out to be a nice, pretty number. Next one. It's a chance to practice rationalizing. So, take the square root, change that sign, so change it to a plus. Square root times the same square root, cancel out. So I'm left with 2x plus 5. That and that are always going to subtract out. Negative 1 times a positive 1 is a negative 1. And the denominator comes along for the ride. Two x plus 5 minus 1 is going to give me 2x plus 4. Which I can factor out of 2. And those are going to divide out. Now we can do direct substitution. Plug in that negative 2, and you get negative 4 plus 5, which is a 1. 1 plus 1 is 2. And all over is just a 1. I'm going to do the next one without talking, so you have a chance to actually, I'm going to pause it and do it, and you can check your answer here in a second. Actually, I changed my mind. I'm going to keep going. If you want to just fast forward and check your answer, you can. This one gets a little tricky. That's why I wanted to keep going. If I factor out a negative 2, I get x squared minus 1. Which the reason I'd want to do that is because x squared minus 1 can be factored. Going to be negative 2 times x plus 1, x minus 1. Now I can do direct substitution. Negative 2 times 2 is negative 4 over 1 plus 1, negative 2. Okay, this next one, I might be showing you a little bit different way than your other teachers taught you. I don't know. I'm going to make these into one big fraction. So I'm just going to multiply this one by x, and this by x plus 2 and x plus 2. So I've got the limit as x approaches 0 of, now they both are going to have the same denominator, so x plus 2, just going to add the numerators up, over x times x plus 2 divided by x. Now if we really think about that, that's 2x plus 2 over x times x plus 2 divided by x, or multiplied by reciprocal. So I end up with two x plus 2 x squared x plus 2. Now even if I factor out a 2, that's going to be 2 times x plus 1. Nothing factors out. X squared still in the denominator, so if I plug in a 0, I'm still going to have a vertical asymptote. So does not exist. There's still going to be a vertical asymptote. Notice the next one's worded a little different. It does say from the right. So we're going to have to take a little bit of time here. Do a little factoring first. Let's see. 3x squared positive 2. The missing things add to be the middle term, and multiply to be 6x squared, which is the first and the last together, which is easy. That's 6 and 1. So I know we have to have a 3x, an x, a 2, and a 1. So I've got 3x plus 1 over x plus 2. Whoops, this must be a 1. And in the denominator, that's difference of squares. Which makes it nice and pretty. So, oh no. Alright, so this is one of those that's coming from the right side. I can't just say it doesn't exist, because I know there's a vertical asymptote there. But if it's coming from the right side, I actually have to figure it out. So coming from the right side, what's just to the right of 2? Well, I don't know, 2.1? So if I put in 2.1, what is the numerator going to be? Well, it's going to be positive. What's the denominator going to be? Positive. So the whole thing is going to be positive. That means this is going to positive infinity. Okay. As x approaches 3 from the right, I can't factor anything, so I need to do one of these things again. So if I take 3.1, sounds good. So let's let x be 3.1. Then I'm going to have positive, positive. Easy way to do it. If I'm coming from the left, so that'd be like 2.9. I have positive, but the denominator would be negative, so the whole thing is going to be negative.